So let's try to work through some probability distributions. Probability distributions, there, that's how you'd say that. So here's the basic question. We'd like to find the expected value of shaking two dice. So you've seen this table before, right? So here's, if I shake on the first dice, 1, 2, 3, 4, 5, or 6. Second dice, 1, 2, 3, 4, 5, or 6. So you can see there's one way we can get a 2, 2 ways to get 3s, 3 ways to 4. So again, the question is, what is the expected value for the sum of shaking 2 dice? So of course, when you just look at the table, you can see that what occurs most often is right here. There we go. You can see there's more 7s than anything, so that's what we would expect the answer to be. Okay? But trying to use this equation here to find the expected value, so what we need to do is take this and build a table first, all right? So here is the sum count. So we could get 2. There's a couple different ways. In fact, here, there's one way we can get a sum of 2. There are 2 ways to get a sum of 3, 3 ways to get a sum of 4, 4 ways to get a sum of 5, 5 ways to get a sum of 6, 6 ways to 7, but then you can see we start counting down now. So we have 5 ways to get a sum of 8, 4 ways to get 9, 3 ways to get a sum of 10, 2 ways to get a sum of 11, and 1 way to get a sum of 12. And of course, this is ridiculous. There's not a way we can get a 13. All right. So far we have a quantity of each of these sums, right? Next question would be, what's the probability? And of course, if you go over here and look, 6 times 6 is 36. So we're saying is, what's the probability of getting the sum count of 2? It'd be 1 out of 36. 2 out of 36, 3 out of 36, 4 out of 36. And let me just fill this all in here. 4 out of 36, 3, 2, So what we have here now is the probability that any one of these events can occur. Now, since you understand how we made this table and put it into here, I need to get rid of this so we can actually now find the expected value. Now again, just looking at the picture, we already know it should be 7 because that's the value that occurs most often. But let's get rid of that. I should maybe give you another example of what we mean by expected value. You can imagine if you walked into a room and the average age is 25, you might expect that the next person you meet would be 25 years old. There's no guarantee of that, but so expected value in many ways is kind of like the average. Okay, so now let's use this equation here to find the expected value. And this takes a bit of time here. So so the first probability, we have 1 of these. So we have 1 times the probability, which is 1 over 36. Add it to the next one. We have 2 times the probability of 2 over 36 plus, you can imagine we do all of these here, right? So let me jump down here to maybe number 10, where we'd have 3 times 3 out of 36 plus 2 times 2 out of 36. I'm going to run out of room. 1 times plus, and here I'll put it here, 1 times 1 out of 36. There we go. So now, again, we have all of these terms. We need to add them up. And it gives us 7, just like we expected. Our expected value is that we would get a sum of 7 when we shake 2 dice. Obviously, you can get a lot of other options, but this is what we expect. So let me make a histogram of our data. This would be a frequency table right here. This is the frequency that these events occurred. So let me just make a quick little graph here. On our x-axis, this will be our sum count. This column right here, so let me put that in here. So we'd have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Then on this axis, we will have the probability. So right here, we're going to put all the probabilities. So you can see here, we would start off at 1, 2, 3, 4, 5, 6. I'll go one more. We don't need it. But so we have 1 out of 32, 2 out of, no, not 32, 36. 36, 2 out of 36, 3 out of 36. So we're just taking these numbers right here. 4 out of 36, 5 out of 36, 6 out of 36. And again, we don't have this big of a number. We stop right there. But I'll put it on. So there's our table. So these are probabilities. This is the count sum, which is over here. And now we're going to make what looks just like a bar chart. So our first one would be right here. Next one, right there. There's a few differences between a histogram and a bar chart. One is histograms, we don't put gaps between the bars. Another thing is the order here is always going to be in order. You'd never scramble these with a histogram. Okay, there's our big one. And of course, what occurs most often is 7, which is what we expect, right? It's our expected value. And then I start counting back down now. Let's see, so I need 2 more here. And last, probability of getting a 12 is 1 out of 36. All right. And one more thing I wanted to do was shade. And so what I like to do is shade that if the probability is greater sum of 8 or greater. And so when you look at this, here is 8 or greater, so shading our histogram would look like this. This is the probability of, right here in yellow, that's the probability of getting a sum of 8 or more. It's adding all of these up. Now, of course, you would also expect if you were to add up all of these, the probability would be equal to 1, right? All right, so I think it's time to go try. So again, this is expected value problem, and let's go try a different kind.